In the last class, we have studied what is data, what is database, what is database management system, what are the applications of database management system, what are the disadvantages of file system, and what are the difference between file system and database management system. In this class, we will be learning levels of abstraction, view of data, instances and schema, data independence. Coming to levels of abstraction. What is the meaning of abstraction? Yes, abstraction is hiding of data. What is needed to hide the data? You know, database contain large amount of data. So, always this database maintains some levels to reach user. So, this type of level or maintaining some levels is known as abstraction, and this abstraction is termed or is maintained in the form of levels. There are three levels. First one is physical level, second one is logical level, and third one is view level. Come, let us switch on to physical level. What is this physical level? Right? This is the lowest level of data abstraction. That means it is present at the lower order. What is present in this physical level? Yes, physical level contains how data is stored. Do you know how data is stored in database? It is stored in the form of blocks. And you know, data structure is used to maintain this database. What is this data structure? How data is stored is maintained by few data structures that we have studied in first year, right? So I think you got a clear idea what is physical level. Next is logical level. This is middle of those two levels, right? First one is physical and second one is logical level, right? So what is described here? Here it is described what type of data is stored or what data is stored in database, right? Yes. Next one is in this logical level. I said that data is stored, but how this data is stored, right? You know, dear students, we will be covering large part of this logical level in our second and third unit, right? Here we will be dealing how data or how this data is termed or what are the attributes of this database can be used will all be written, and we will be seeing how the relationship between those things will be maintained and these are stored. And last one is view level. This is the last level of levels of abstraction. Can you guess the definition of view level? Yes, it is there from the word itself, view. This view level is the highest level of data abstraction and it helps the user to interact with database. Do you know how user will interact with database? Yes, it maintains a graphical user interface where a user, by using any graphical user interface, he will interact with the database. And here we will be seeing that it hides all the data. You won't be aware or user will not be aware how data is stored and what data is stored. All such details are hidden from the user. Can you see the previous levels of abstractions are termed in the form of a figure? This is view of data. See, can you see this? View 1, view 2, view 3 and so on. That means there can be any number of users can interact in view level. That means, as I said, that database has concurrency. There is no problem when many users interact with database. So the view levels have given in many numbers, right? And second is logical level, and the last level is, or the lowest level of this level of abstraction is physical level. Next, we will see some few definitions of database, right? So, as I said that this is a new subject, we will have many new terms to be learned, right? So in the same way, we will be learning what are these instances and what are these schema. What is instance? You know what is instance? It is actual content of database at that particular time. At that particular time, what is the value? Is termed in the form of instance. Example, value of a variable. What is the value of a variable at that particular time? Yes. In the same way, we will be using these instances in our programming language also by having variables, etc. What is schema? It is the logical structure of database, right? So here we will be having how database can be organized. Yes, so here an example have been taken, set of customers and accounts. Customers, what is this customers? Customers name, their ID or their phone number, etc. Accounts deals with account ID, account number, transaction ID, and so on. This schema has two types, physical schema and logical schema. Database design at physical level is known as physical schema. Database design at logical level is known as logical schema, right? Here is there an example taken of an university, how the database is maintained. See what is present in conceptual schema. Student information, which is termed in SID, that means student ID, name, login, age, GPA, and here string. These are all the data types that have been mentioned. In C language, we have used int a or int number. That means data type is written at the front, but here we will be writing data type afterwards, right? So in the conceptual schema, there are three tables that have been taken, or three entities that have been taken, that is students, courses and enrolled. In courses, some information is termed in the form of CID, CNAME and credits, and enrolled, SID, CID and grade. So here we will be seeing you can take any number of properties that belongs to student. You can take any number of properties that belongs to courses. You can take this is termed as a relationship between student and courses, right? Next one is physical schema. Here, as I said, that it deals with how data is stored. So here we will be seeing how data will be stored in the form of unordered files, and here it maintains an index by taking student ID as the first column, in order, because it will be easy to search the student records. And finally, external schema, that means for the user it is seen like this: course info, only the necessary things will be seen for the user, right? Next one is data independence, right? So can you know what is data independence? Ability to modify the schema in one level without affecting schema in next higher level is known as data independence. This definition is little bit tricky, but it is important. So whenever you want to change the data at one level, ensure that it should not affect the level in another, right? Because as I said, the database deals with large amount of data. So once you try to configure everything, you can make the changes in the same level, but it should not affect in the other level. That is known as data independence, and each level, in physical level or conceptual level or view level, it maintains data independence, right? So how they are maintained? Logical data independence, right? The ability to modify logical schema without affecting the schema in the next higher level. What is the next higher level of logical level? That is external schema, right? Next one is physical data independence. The same, just we have studied for logical data independence, the same we will be studying for physical data independence. The ability to modify the physical schema without changing logical schema. So you can change anything in that level without affecting to the next higher level. The next higher level for logical data independence is external schema. The next higher level for physical data independence is logical schema. There are different data models. data models. That means data can be represented in different models. So first one is relational model, next one is ER model, object based data model, and semi-structured data model, and there are many other types of models, that is network model and hierarchical model. Relational model we will be covering in the second unit. Entity relation model we will be covering in the first unit. Relational model deals with relations. That means here we will be using tables, right? Data is stored in the form of tables, and these tables we will maintain relationship between one table to another table in relational model. ER model was older than relational model. First we must learn actually ER model, because it is just like designing part, where we will be learning how entity and attributes can be designed, and how we can establish relationship between entity and entity, right? So object based data model, it depends upon some of the features of object oriented model. Here the table is termed or is taken as the form of object. So it came into existence in late 1980s to 1990s. Next one is semi-structured data model, where we will be using XML, that is extended markup language, in order to interact with the database. And older models, before ER model came into existence, there were very little bit difficult models that have been used, that is network model and hierarchical model. Network model will be having many entities related with each other. In hierarchical model it will be in tree-like structure, where information is stored in the form of nodes, and it is in the form of tree-like structure. Coming to just have a glance look of this relational model, because again we will be learning brief on this part of model, that is relational model. As I said that relational model maintains tables, data is stored in the form of tables, right? So here is an example of a customer table, where customer ID, customer name, customer street, customer city, and customer, all the information pertaining to customer is stored in the form of table. So this is a sample relational database where many tables are there. This is customer table, this is account table, and this is depositor table. So whatever information, whatever columns you want to specify, you can enter. There is no restriction. So according to the given data available, we can enter n number of columns for a particular table. Next one is ER model. Let us have a glance look how ER model looks like. Entity relationship model. Entity is a thing or object in the real world. Anything you can take as a thing or object is termed as an entity. So how to represent this entity? Entities are represented as rectangular boxes. So for explaining the properties of entity, we are having attributes. What are these attributes? If I want to describe any property of a particular object, then I want some verb forms to be taken that are known as attributes. Example, student. What is student? Student is an entity. What are attributes of student? Properties of student, that is roll number, his address, his mail ID, his PAN card number or Aadhaar card number, all information about a student is known as attributes, and these are represented by ellipse shape. What is the relationship between two entities? As I said that we are using a relational model or a relation between two entities or two tables. So there should be relationship. What type of relationship that you can use? So this relationship is maintained in the form of diamonds, and lines are used to connect between those entities and relationship. This is object oriented database model, where we will be termed objects as a database, and in database we are having two main languages, that is DDL and DML language. DDL stands for data definition language, and DML stands for data manipulation language. We will be learning this in the